This is video number 4, and actually after I finished number 3 and realized I need to cover a little bit about the battery basics before we actually get into the charging. Now, I'll admit one thing, I'm not a battery expert, so if there's someone out there that believes that my methodology is incorrect, please let me know so I don't mislead everybody by this. But what I have found is I prefer to use the lead-acid gel cells, or actually the lead-acid standard battery like an auto battery. And what I use for what I'll explain here is an electronic load. And this electronic load allows me to, after I have charged a battery, by the manufacturer specifications at the recommended charge rate for a recommended period of time or top-off voltage, then I will take and connect the battery to the electronic load and discharge the battery to a particular point over a period of time at a constant current. Now, if we take and charge this battery and discharge it, we can develop a graph over time of what the discharge rate looks like and what the slope is. Then if we put it on something that is supposed to be charging the battery also, like this particular circuit, we can take and charge it to a voltage which corresponds to the manufacturer's literature and to what we have priorly used on testing the battery normally to derive its first curve. We then take and charge it with the cell to a specific voltage, disconnect it, hook it into the electronic load, and discharge it at the same rate and current as we did the battery when it was charged to manufacturer specifications. What we will end up here with is an indication of, does the battery discharge slower or faster as compared to the normal manufacturer's charge specification. Now, what this tells us is, did we charge it better or did we charge it less? If this thing discharges faster in the electronic load from the same voltage indication, then we have not really charged that battery properly from whatever device we're using to do it with. So you need to get the specifications on the particular battery you're using. You need to get it charged properly. Then you need to discharge it. And then you take and hook it to your device that's going to charge it and discharge it again and see how they compare. Now, if you don't have an electronic load, they are expensive. If you don't have one, what you can do is you can do something very similar, in that you can take and hook a fixed resistance, a high wattage resistor, across the battery and discharge it over a particular period of time and also derive a discharge curve from that. Now, in my case, what I'm doing is I'm discharging at a set current regardless of what the voltage is. So the instrument actually adjusts the resistance to keep that current constant. But in the case of the resistor, you will have a diminishing current as the voltage decreases across the battery. But as long as you do it in a similar fashion, now this is my way of thinking, and if you're a battery expert, correct me, but as long as you discharge it into that resistor in a similar fashion after you've done it to manufacturer specification and then derived your curve, then do it after you've charged it from the cell, you should see a very similar indication to what I see when I use the electronic load. And if you don't do it this way, you can't go by voltage alone, because we have the phantom voltage, the phantom charge. It will look like it has charge to a particular voltage, and the minute you hook a load to it, bam, it's back down to practically your beginning point. You put very little current into it. You have very little energy. You can call it phantom voltage, phantom charge, pseudo, whatever, but it's incorrect. And of course, unless you have something to refer that to, you're not going to know for sure if that is a phantom or what exactly is taking place. So you have to establish that point of reference. And I realize it's tedious. That's the way life is when you do this. It's very tedious. So you've got to get familiar. You have to establish a protocol that you can follow to understand what is happening with this battery when it's being charged the normal way and when it's being charged from a cell. Because what we're obviously after is we want the result to be identical. We want the cell to charge this battery with meaningful real current and take it to our set voltage or the voltage we want to arrive at, and the battery will discharge with the same effective energy as what it would if we did it to manufacturer specification from a battery charger. So if you have an electronic load, duck soup. You hook that to your computer, it's all automated. If you can't, get a high wattage resistor, determine what current you're going to discharge it at, and do it into the resistor. But if you don't follow that, you're wasting your time. You have no reason to even proceed, because you're not going to be talking apples and apples. You're going to be talking apples and oranges.